Yes, thank you.
Ah, there we
Yeah.
go.
Yeah.
Okay, let's see. Okay, good evening, everyone. The purpose of this talk tonight is to give you an overview of the latest updates on soaring weather services and tips, workflow for briefing yourself for a soaring forecast. And of course, being a retired meteorologist, I'm a little more intense about doing that. So I'll take you through nonetheless the internet websites that I favor these days. The first step in getting a briefing for the soaring forecast, whether it's tomorrow or anytime in the next 5 or 6 days, there's really no point in going that much than 5 or 6 days, is to get the big picture. Rather than just going to directly to soaring forecast sites like SkySite, for example, which is my favorite. So, but before I do that, I want to talk a little bit. I'm going to be showing you high and low patterns on general weather websites, troughs and ridges, and all those weather geeky kind of things. So I'm going to give you a quick 7-slide review of the rules of thumb for evaluating weather maps and how it relates to soaring. After you've gotten the big picture, you go to a specific soaring site like SkySite or Top Meteo. And then I always look at the National Weather Service, the public forecasts and discussions. And I'll show an example of that. We won't have any soaring weather to look at much around the region today. We're in midwinter, but we'll have some interesting weather to look at. Finally, observational data. That means satellite imagery, radar, other surface observation sites. I got three or four places that I go to that are excellent. And the last is an optional section on 12 to 24-hour forecast. When you're looking at tomorrow morning you need to do a quick update. I have some sources I go to for that because they're updated most frequently. So get the big picture. So if all you want is a soaring weather, why do you have to get the big picture? Well, there's a couple of good reasons for that. One is you learn. Let's see. Do you see this bar at the top of the screen here for sharing? No. I want it to go away. Okay, I just want to make sure that's not going to be in the way. So by looking at the general weather patterns on the large scale, first of all, you learn what kind of patterns produce good soaring, poor soaring situations. But it's really a great idea to look at the large scales. And for that, we have global models. They go by acronyms. The NOAA model is the Global Forecast System, or GFS. The one of choice that we use even in the National Weather Service meteorological community is the European model. Their global model is one of the finest in the world as far as performance and resolution. And Windy does a great job of looking at that. We'll show examples shortly. ICON is the global model from the German Weather Service. And then we have two models called the HRRR and the NAM 3 kilometer. These are high enough resolution models. They're called cloud resolving, actually thunderstorm or shower resolving models. And they're from NOAA. And they provide a lot more detail, but don't go that far out into the future. Well, the longer term outlooks will assist in choosing the right soaring day. Sometimes you're not going to fly tomorrow. If you're retired like I am, and some of you other white-bearded and white-haired people out there, you have a little more flexibility in picking your day. So here are some of the rules of thumbs that I use before I show you the weather maps, highs, lows, and troughs. So these are all going to be summer scenarios, but what I'm looking at here is a 500 millibar chart. The black lines are pressure lines. Low pressure up here, high pressure over there. Actually, when you look at upper air charts, you're looking at a pressure surface, the height of, but you can think of it as just high and low pressure areas. So this is when we get in the summertime and we have a trough approaching the coast, and The rule of thumb that I want you to come away with here is that in the upper right-hand corner or in the area preceding the trough, like right in this green region here, this is an area of low velocity lifting and destabilizing air. If that sits there long enough, produces clouds, thunderstorms sometimes, and if you're far enough out and the air mass is dry in the central plateau of Utah, of the Great Basin, this will produce some spectacular soaring conditions, as long as it doesn't develop thunderstorms. When you have a cutoff low, again at 500 millibars. By the way, what is this magic thing? Why do we always look at 500 millibars? Well, in meteorology, 500 millibars, 18,000 feet roughly, is about the midpoint of a troposphere. The top of it is about 30 to 40,000 feet, the surface. So this is the mid-level, and it's a good reference level for where weather systems translate around the world from west to east. So if you have a trough which cuts off into a low, the northeast quadrant is where you get lifting motion. And if it's moist enough, or if this sits here long enough, particularly in the summer and late spring months, this will develop a lot of cloud cover, and those little red squiggly symbols indicate thunderstorms in the code, the icons used in meteorology. Here's another pattern, a very, what we call zonal flow, a weak trough up here in the Pacific Northwest, and an elongated east-west high pressure over Southern California to New Mexico. Again, lifting motion ahead of the trough, subsiding air mass under the high pressure area. Those are rules of thumb that that tends to suppress thermal convection when you have a high center like that, center near the four corners, right in the center. The blue lines represent the low-level flow, and this is not particularly a good pattern for soaring in the Mojave Desert and Sierras because it brings in the stable air from the ocean or from the coastal regions of California. First a northwest flow down the San Joaquin Valley, and then it bends around, becomes a southwest flow into Nevada. Example number 4. This is actually a really, really good pattern for long cross-country flights. And the reason is that we have a cutoff low to the west of Los Angeles or southwest of San Francisco. And the circulation around this destabilizes and lifts the air mass. As long as it's dry, it's going to stretch and destabilize the lapse rate. But at the same time, this high pressure up here in northern Nevada is dry and has a deep, clear sky, a deep thermal layer, clear skies, many days of sunshine, and it's not unusual to see over 20,000 feet or more MSL for thermal heights. So when you're right on the edge of this and you have an east and southeast flow, this can be a very good soaring pattern. Another one that's common is the monsoon flow that from the high pressure centered over the four corners here. The easterly flow on the south side of it brings in old moisture and clouds, the debris cloudiness from thunderstorms in northern Mexico. And as long as it doesn't inundate Southern California and the Owens Valley, this can be a good soaring pattern. Usually it doesn't last long, and this moisture gets in here, and we end up with too much cloud cover, which reduces the height of thermals in the Mojave Desert, Owens Valley, if not just generating thunderstorms within a day after you see this kind of pattern. Again, near the high center, subsidence and drying, and that's the takeaway on this particular slide. The sixth one, gee, I think this is a duplicate. Sorry about that. You might think if we have high temperatures of 105 or 110 degrees in the Mojave Desert, that would be great for soaring, but it's not. This is a situation of a strong high pressure aloft centered over California. And you tend to have subsidence, which suppresses thermal heights. They might go to 15 or 16,000 feet, but because of the subsidence above the thermal layer, it really greatly delays thermals starting. And these are the kind of situations where you get around to 1:30, 2:30, 3 o'clock in the afternoon to get going over the mountains. So having an extremely hot day at the surface temperature isn't necessarily a great soaring pattern, because you need a little bit of lifting motion to keep that thermal layer, which develops and dissipates after every day, remaining fairly deep. So I found over the last couple of years that windy.com is the best site for looking at the large scales. It's very easy to use. We'll show you here an example in a second, and compare it to weather. It allows you to compare weather patterns from about 5 different numerical weather prediction models, notably the European model and the global model, the GFS. And that's important because SkySight, which is the final source we're going to look at for thermal heights, is based on the GFS model. So by looking at this, you get 2 views of where the major high pressure systems are going to be in the next couple of days, troughs and weather patterns. The second choice is this NOAA website, mag.ncep.noaa.gov. I'll just give you a brief glimpse at that. So now I want to do a new share, and let's see. Where's my website? I need to get things set up here to share this. It's not intuitive and fast. Windy.com. There it is. Now, where is it? I just displayed it on my computer, but I do not see it amongst the shareable screens that I have here. Let's just try that. There we go. Is that the windy.com website? Somebody give me an acknowledgement there, a thumbs up or something. Do you?
No, it's
just not, that's not the Windy.
Okay, so
It's
now
go.
screen sharing.
Yeah, click on the screen sharing button, and then you should have, if you have it open on your
A
desktop.
new share. There we go. There it is. Okay, now we got it. That should update. There we go.
There we go.
Okay. All right, this is the main Windy website, and I need to get, there's some pictures overlying this. I need to get the gallery to go away. How do I get the gallery to go away? There it is. It went away.
Yeah.
Okay. The thing that you want to look at here is you can zoom in to, or you can zoom out to see the whole northern and southern hemisphere. And what we're looking at here are winds. The whites and colors are wind speeds that vary from 0 to actually about 200 knots. This white in here is 200 knots. Let's see. It's 120 knots. So the coloration here are the wind speeds. This little slider bar takes you to the level you want. I'm using 18,000 feet, 500 millibars. And whoops, don't want that. You can look at the troughs and ridges. This is valid. Let's see, where are we right now? We are, yep, Wednesday about, let's see, what time is that? 0600 Zulu. You can take your mouse and you can drag this along and go through several days of forecasts, looking at the progression of trough. This is just This trough going through here for California is the big rain day on Monday. We're going to have another one on Sunday. The lines here are the height lines or pressure lines at 500 millibars. Here's the trough axis. And that big white area right there is some high winds.
This is interesting.
110 knots at 18,000 feet.
Bob Caldwell.
No. It's Walt Rogers.
Oh,
Hello,
wow.
Bob. All the way from Colorado, huh?
That's Bob.
That's Bob.
Please mute if you can, please.
So with this website, you can pick any level you want to look at. I'm picking at the mid-troposphere, 500 millibars, and drag it along time-wise. And you can go actually out to, I think it's 7 days. Where are we, Wednesday? I think it goes out to 7 days here. Very, very handy. What else do we have here? Wind gusts. These are surface wind gusts. I think that's what this is. Rain and thunder. The rain areas are blues and greens. The little icons that look like lightning strokes are out here off the coast. And if you want to just look at that level, I think you can, oh, there's a little button here. You can turn this on to pressure. Now you have sea level pressure. High pressure over the Great Basin right now, Nevada. Snow showing up here and then the northern Sierras, indicated by the snowflakes. At any point, you can right click on this and show a weather picker, and that's actually rainfall. I think it's, yeah, it says 3-hour rainfall. So that's very handy. Let's see, what is it out here in the ocean? 77 hundredths of an inch every 3 hours. So if you wanted to get a sounding there, go to this. Oh, if you wanted to get a meteogram for that point, that looks like west of Williams up in the mountains there of Northern California. Let's see, I can't tell where it was. Sacramento. Here's Sacramento. So here's a meteogram, which is time versus some parameter or to look at what's going on weather-wise at that point. Let's see, if you hit aerogram, meteogram, here's the one I like to see. These are the times, local time at the top here, Wednesday, Thursday. The gray areas are nighttime, the white areas are daytime. You've got temperature. Where's temperature? These are in degrees C. Is that right? That can't be right. Is it that cold up there? Ah, that's better. Now we're at this point. 10 degrees C. By the way, this menu up here, or the pancake menu, you can go to settings and you can turn this to Fahrenheit if you wanted to. And then if I go to the meteogram, let's see. Let's see, meteogram. There we go. Temperature in Fahrenheit, you can see how it's varying. You see winds here. They're in 16 points of a compass with little arrows. They're 3 or 4 knots, very, very light. And this is a depiction of cloud cover from, it's hard to read this, but this is about, I think, 5, 10, oh, this is 30,000 feet down to the surface. And you can see the extent of high clouds, middle clouds, low clouds, the rainfall, and these little bar graphs here. And as time goes on, there's a little clearing on Thursday for that point, and then another area of rain, and then a clear day relatively in here on Sunday, and so forth. You can actually extend this out to much farther in time, all the way to Friday. end of the week, looking at cloud cover, where the rain's going to be. Now, this isn't going to give you a soaring forecast. This is giving you the big picture for a point, and you can easily look at the weather systems that are producing it. You can even get weather rain accumulation. Here's for the next 3 days at this point. What does it amount to? Let's see. No, that's not what I wanted. That's not what I want. By the way, these little circles on here are airport locations. And when I mouse over it, I'm getting the meteor observation at those points. There's a way to turn that off. It can be annoying when you're panning around here, but let's try this point again here. Show weather picker. There we go, 4.64 inches over the next 3 days. And we're looking at rain accumulation. Pretty cool, right? You're going to be going over Donner Summit. Let's see. It shows rain. Let's go to snow. 6.4 inches of snow over the next 3 days. This is, again, you look at what you pick what you want to look at over here. You can pan around, zoom and pan, and then you look at the model. The model of choice is the European ECMWF. You can look at it for the GFS model. It's about the same. And then we have a couple of higher resolution models here. The HER model, it only goes out to not very far. Here, I just switched the winds. Let me turn off pressure here. That's confusing. By the way, when you turn off the pressure in isobars, you don't want to see surface pressure when you've got a map of winds at 500 millibars. See, I have this at 500. You have to go down here to this extra menu and drag it down to geopotential height. And then when you do that, you get the pressure values for the troughs and bridges. Well, this HER model doesn't go out very far. It only goes out to about 48 hours. So it runs out of time pretty quick over here. But you can look at rain from that model, see where it's going to be. That's Friday night. The GFS shows the rain in the Santa Maria Vandenberg area. And the European model. If you look at the European model, this has 9-kilometer resolution. And the GFS model is 13-kilometer resolution, except it looks a lot fuzzier than that. And the reason for that is that you're only able to get 25-kilometer grids. So the GFS model is reasonably accurate, but the European model really stands out as providing a lot of detail. For example, the European model is a better model than the NAM model that we had for only went out 84 hours. But this is global. It's far more accuracy and capability. So it turns out that we used to use a whole cascade of different models that are higher resolution and shorter time frames all the way up to the global models. But it's turning out the global models are getting to be so good that you can use that as a starting point. And in fact, that's what Matthew Scudder does for SkySight. He's using that to initialize the higher resolution 3 or 4 kilometer model, which is the one we get our soaring forecast from. Let's see, what else do I have here? Clouds. You can, if you go to this extra menu, you can actually see cloud tops. I'm looking at the European model, 1400 local time, 2200 Zulu. And if you want to know what the cloud tops are, well, you just right click on this somewhere with a weather picker. And there they are. If you wanted to look at low clouds or cloud bases, there it is. 5,400 feet. This is between San Luis Obispo and Monterey. Out in the desert here, I know it was pretty clear. Or you could just look at clouds, high clouds only. This is the coverage of the high clouds, coverage of the medium clouds, coverage of the low clouds. And all of this is very easy to scan backward and forward in time with. Is it going to be a cloudy day? That's an important factor for a soaring forecast. Now you can get a lot of this information on SkySight. We'll show it in a moment. SkySight will do 6 days out, but only between 8 a.m. and 8 p.m. That's how he's able to do this. He just initializes each day from the GFS model. All the temperature parameters, winds, moisture, cloud cover, all that starts as initialization. He runs the model for about 14 hours, and that's how we get the detail in the soaring forecast. So there is some rain going through here on Saturday for Southern California. Let me go back to my rain and thunder. See, that's a pretty good rainstorm frontal zone going through. This is noon, 11 a.m. That's 7 p.m. 0300 Zulu Saturday night coming up. So another thing that's very useful are all these other parameters. The most notable one is there is a thermals forecast. Now, yeah, I have to put it somewhere in the middle of the day. See if anything shows up. There it is. This is from the European model. And it's fairly good. It's not as good as SkySight and Top Meteo, but you have a crude way of getting thermal heights. I have to go to New Mexico to show anything here because the Mojave Desert is 0. That's the time when we're getting our front going through the area. By the way, waves are ocean waves. They're not mountain waves. There's tidal currents, aerosols, lots of different things to experiment with here. One of the things I will look at is when I'm looking for an update, I'm at the European model. Oh, by the way, the SkySight is free, although there is a premium version. The free version of windy.com gets most of this information, but you only get 3 hourly information. I'm on the premium version. If you take a look up here in the upper right corner, it says premium, $19 a year. Very, very inexpensive. But you can do most of what I'm looking at here with just the free tier. And the only real advantage you'll notice is you'll get hourly data, which is useful for satellite and some of the high resolution models. Let me get out of, let me go back to winds here at 500 millibars. Let's see. So the premium version is required if you want that soaring thermal height. The European model, if you go to information, it tells you a little bit about it. It says it was updated 2 hours, 58 minutes ago. It's only updated every 6 hours. Oh, the other one, the premium version, you get an updates every 6 hours. It's every 12 hours with the regular free version. Most of the models update the GFS model, the HER model, update every 6 hours for the version that goes out to 48 hours on the high. I use the word HER. HRRR is in meteorological parlance. It's called HER. H like he, her. In another year and a half or 2 years from now, we're going to have the RRFS, which is Rufus. So anyway, we have our slang for types of weather models. Let's see. So the European model here, let's go to information. I always like to, it was updated at 1800 Zulu, which is 10 a.m. this morning. And the new version will come out in about 3 hours. And that'll be the 0Z version, which is 4 p.m. today. Takes about 6 hours from observation time to get a full run of this global model. It's worth the wait, though. The GFS here, if you go to information, it already updated. It's at 18Z. Oh, Okay, I thought we might have a 0Z version. It's a little too early for the 0Z version. Any rate, so you can vary altitudes here. You can get a lot of surface information. My God, it's really worth experimenting with all the things you can do with this. But the big picture that's going to set the stage for soaring is the point. Now, there is a website called mag.ncep.noaa.gov. And this is the NOAA National Weather Service version for their model sites. We already have some 0Z models in here. And if I go back, let me go to the beginning of this. Model, analysis, graphics, MAG. You go to model guidance. You pick the model you want. Most of these you won't recognize, but the ones you would want to use are the global model, the HER model, or the NAM high res. These are both the NAM high res and the HER are 3-kilometer models. But the GFS is 13 kilometers, but you only see 25-kilometer grids. Then once you pick the model type, you pick the region, CONUS, which means in the United States. And I like to look at, well, I like to look at 500 millibar vorticity. Well, the data just started coming in, so it isn't very, hasn't gotten very long yet. But that's what it looks like. The solid lines are pressure lines or heights. The green and red areas are vorticity, which is to say where the turning motion, whether is cyclonic or anticyclonic. And the bright red areas are where there's a lot of wind shear on the left side of the jet stream or along a sharp trough line. So weather people like to look at that. You might find it easier to just go to 500 millibar winds and height. And you just see wind barbs. For those of you who don't know what wind barbs are in meteorological parlance, these things with 2, 3, and 4 flags on them indicate 30, 40 knots. When you get a solid flag that's filled in, that's 50. Let me stop this. Here's one here. It's a big 50-knot flag and a 1 barb. That'd be 60-knot winds. You can go back and pick other parameters. A lot of things I like to look at here are precip, 3-hour precipitation. You can also get simulated radar. I think there's snow in here too somewhere. Well, I guess not. It's just precipitation. Okay, so here's the global model GFS, and you can see the rain areas, and then the solid thin lines are surface pressure. Okay, if you want a little more detail in your work here, you could go to NAM high resolution. Pick the southwestern US, and let's see what it says for 1 hour precip. This only goes out to about 60 hours. But you can see frontal zones and rain moving in and things like that. The one thing that is missing that's important, that is on windy, you don't have any cloud cover on here. Just relative humidity, surface winds, winds aloft is pretty much it. But it meets the criteria for the big scale view. So I am now going to do a new share and go back to my slide. So once you have the big picture, I didn't want to do that. Here we go. Once you have the big picture, you go to the details, go to the soaring sites. In order of my preference, I actually just use SkySight right now. SkySight.io is the URL. They're 0 to 6 day forecasts. They only run from 8 a.m. to 8 p.m. local time, since those are basically daylight hours in the summertime. It really does everything you'll want to know, and I know you've seen this many times. Some of you are routinely using it like I am, perhaps more so than I am, since you're flying more than I am right now. Top Meteo is the other large commercially available website. It's available for the US, has a very different user interface. It's simpler to interpret. They recently added convergence lines, just like SkySight has, and mountain waves for Europe. SkySight has both convergence lines and mountain waves for all its regions around the world, including the United States, which we use a lot here in the California and Sierras. Incidentally, SkySight's $79 a year. You can get it for $10 a month if you want to go month to month. Top Meteo has a lot of variety of plans, anywhere from $20 or $30 for a quarter, or for a limited region, up to $160 a year, depending on what you're going to look at. There is an older website that actually is quite good, xcskies.com. It's still working. It's still showing all the National Weather Service and NOAA models, and the soaring parameters, just like we see in SkySight and Dr. Jack. You might ask, well, why am I not using XC Skies? Well, the reason is that SkySight is just so much easier to use and has so many other features for soaring that make sense. It's easy to go from days 1, 2, 3, 4, and 5. With SkySight, XC Skies, it's much more difficult. I'm not going to show you that tonight. $40 a year for XC Skies. drjack.net with BlipMap is free. You just have to register with it. It's older. It's based on the NAM, although based on you guys up in Northern California, Brian, it actually does a pretty good job showing cloud bases and thermal heights, even though it has an older model. And then the last choice are the RASP community models. These are high resolution regional models. People are running them on small servers or home computers, and they work quite well if they're well tended by somebody who keeps it up. And fortunately, in Central California, you've got somebody to do that, but that's not the case at many regions, including Southern California here. I just find it so much easier to use SkySight. I don't even bother looking at these RASP sites, even if there is one in my region. There's only so much data you can look at in the morning, and that's why I'm limiting my choices to the Big View and with windy.com and SkySight. So we'll just do a quick look at SkySight. I'm not going to spend much time on this. Let's see. I got to go to, let's see. Here we go. Share. Oh, I don't have it running. Okay, just a quick refamiliarity. When in the wintertime, you see a lot of this, which means rain. Not only no soaring or near surface-based thermal layer, but rain. The nearest region out here, I'm looking at Wednesday. You got to look at the date. You got to look at the time, 0800 to 2000, which is 8 p.m. This is 2 p.m. today, Wednesday. And you see a little bit of thermal heights out here in New Mexico. If you want a point forecast, let's point at the Antelope Valley Soaring Club. It shows your thermal height above ground level is 0 for Wednesday, or pretty near 0. And cloud cover, low, middle, and high. A year ago or so, Matthew added, he puts in 3 days now, 8 a.m. to 8 p.m. on 3 days. So you can look at 3 thermal cycle days with this. And then down here, we have surface temperature, winds, and I never look at pressure here. It's not of use to me. Thermal strength is useful. 0.6 knots there in the Mojave Desert, probably do about 500 AGL today at this point. Let's see, point forecasts, skew T's. If you wanted a skew T here, you click on that, point here. There it is. You can see the height of the thermal layer at 2 o'clock. Doesn't look very high, does it? 4,700 feet. What is the ground out there, Christopher? What, 3,000, 2,800? Gee, you know, we should have seen a 2,000 foot thermal layer today, shouldn't we?
Right, 2000.
Yeah, I don't know why it didn't show that. Let me see, thermal height of thermals. My mouse got lost here. Where did it go? Uh-oh. That's interesting. I can't get my mouse back. What happened?
Uh-oh.
Well, it's on the right-hand screen. Well, let me come back.
Uh-oh.
Murphy's Law.
There it is.
Ah, there we go. I found it. There it is. How come we don't see any thermal heights here? That's just kind of strange. Sometimes in the wintertime, I like to go to depth above ground, but even then it doesn't show anything. I don't know what's going on there.
Hmm.
The mysteries of looking at weather. Cumulus cloud base, overdevelopment. You want to look at cloud cover whenever you're doing a soaring forecast. There is a cloud cover in here somewhere. There it is. Where's my cloud cover? It's down here. I know that. I'm looking for another cloud cover.
If you solve this
There- oh,
problem,
there
I'm
it
gonna
is,
be
right there.
very appreciative.
There it is. I
I've
found
got
it.
yeah,
They have one map,
Oh,
which is 3 different colors. Red is high clouds, green is middle clouds, and this saves time. And you can see if there's what's moving in. 10:30, 11 a.m. today. A lot of high clouds in the Mojave Desert, but thin. It was probably pretty thin today. And then as we move till sunset, we're getting some middle clouds in. So really important to look at that, and thunderstorm development, which of course we don't have today. Okay, enough of SkySight. Let me go back to a new share. This. Start from current slide. Okay. So that was the part about, there's where you get the details. If you only looked at that, you wouldn't have the bigger view of what's going on. But sometimes you just don't want to bother spending the time looking at the big picture, but I recommend you get in the habit of doing it. You have to get really familiar with these websites to make it go fast. Otherwise, you'd never got to a glider part in the morning if you did this in the morning. You'd be examining weather all day. The other thing that I like to look at are the National Weather Service sites, weather.gov, the forecast offices. You can easily get to it with, I'll show you in a moment. I look at the public forecast, the text, and the forecaster discussions. And lastly, there's an hourly time series plot for any location. So I'm going to go to that right now. New share on that. And we'll open a tab here. What I do is I don't even have it bookmarked. I just go weather.gov. Well, we'll do it this way, weather.gov. And then you just point on where you want to look at, roughly. And you will get the forecast. Well, that's Las Vegas. That's no good. Let's go to somewhere new. This is the Los Angeles area. There's the Las Vegas area. The forecast offices have these weird gerrymandered zones that they forecast for. And you can see the office there. There's Los Angeles. You'll click on that. You see the significant weather screen for that day. You can then point at the place you want. The San Bernardino County line here, southeast east of Palmdale, is close to the Antelope Valley Soaring Club. So I left click on that. And here is, if I go to 3-day history, well, I don't have a weather observation out there.
Hmm.
You know, if I would have been closer. So you pan down on this and you see the detailed forecast for that point. I pointed to the Antelope Valley Soaring Club site. Here it is. It's east of Palmdale, between Palmdale and Victorville. And if I clicked on Palmdale, then I would show the current conditions at Palmdale Air Force Plant, which is near my house here. If you go to 3-day history, you can actually see the weather observation. Here's a graph of temperature and humidity. Here are all the winds. And what's interesting about this is it's 5-minute data. You don't see that normally with the cloud cover, winds, and everything. So if you got a big storm going through, you can see what the ceilings are. And I think it browses, but well, it goes back 3 days. So that's pretty cool if you wanted to look at that. So you browse through the local forecast here. That's useful. If you want to see a time series for that point, I'm now pointing at near Palmdale. You can see temperature in red, dew point in green. Well, we're already wrote into looking at overnight. So it shows light east, northeast winds, 6 or 7 miles an hour. And then it picks up to 10 to 15, gust 22 tomorrow afternoon. And then, let's see, tomorrow is Thursday. If I go forward 2 days, Saturday. Now, you can see Saturday, early Saturday morning, the rain moves in. And it shows how much rain they expect. 1/10 of an inch. These are every 3 hours. Is it every 3 hours or 6 hours? I think it's every 3 hours.
Like 3 hours.
Yeah. And you can, blue is cloud cover, green is humidity. Did I get that right? Yep. And if there's snow, it would indicate snow down on this line here. And then you can go forward again. You can see, you can easily see which are going to be the windiest days for any given point. And then lastly, when you're on this is the website for a forecast office, and they all look about the same no matter where you are in the country. They're all very similar. I need to back arrow up this a bit. Okay, here it is. This is the public forecast text. Forecast discussion. You read this, the synopsis really highlights what the important things are. It talks about a front coming through on the weekend with rain spreading over the area. And then down here, I'm not going to read this, but it talks a lot more detail with the models and the reasoning behind it and how much rain is expected. In the summertime, they usually talk about the marine layer, which we could care less about, or afternoon thunderstorms. They don't talk about beautiful fields of fair weather cumulus in the desert. They could care less about that. That's called partly cloudy. But any rate, so I look at the National Weather Service Forecast Office websites to see these guys have been doing this forever. These guys down here, these are the forecasters. They've been around forever. They've got 30 years, probably not 40 years. Or if they had 40 or 43 years, they'd be retired, but they're getting there. Lots of experience. I didn't work directly with them. I worked in my own office up here at the Air Traffic Control Center. Not far from where they process NOTAMs for aviation. That was in the news today, wasn't it?
It was, yeah.
Okay. So now I'm going to go to a new share, back to my slide. Okay. observational data. This step of the process is simply this. Don't forget to look out the window before you go soaring that day, right?
Yeah.
Open the, and the version of that for meteorologists and the internet for looking are the observational data, satellite imagery. I'm not going to go through all this. I'm kind of dragging out here. It's 8 o'clock already. But I do have the website for that. This is my site of choice. All these websites, windy.com, SkySite, every single one of them have their intricacies for navigating. And weather.college of DuPage, cod.edu, SatRad, has a tricky way of getting to the satellite imagery. If any of you are a little having difficulty with navigating that, I can show you that some other time. Or if you want me to show it to you now, I can. Radar, I have a website called the Radar Mosaicing System. Whoops, where did it go? You go to this website. It's a little tricky getting to the data, but it mosaics all the Doppler weather radars, and you can go backward and forward easily, zoom and pan, make it transparent so you can see the map under it. That's great. And you can even go with a bit of careful navigating of a calendar. You can actually go back several months and look at radar with this website. And that's kind of unique amongst the mosaicing websites. You can't do that with your ordinary app on your phone. And a lot of the commercial versions you would have to buy to do that. But with this open source version, these are people who have developed this at the University of Oklahoma, really talented programmers and developers. And it became so popular, integrating all the Doppler weather radars and mosaicing it and quality controlling it, that it's universally used now by the FAA and the National Weather Service. So this is a particular viewer for looking at that, but even some of the commercial sources are using this MRMS website. For having something in my pocket when I'm out at the airport, I use an app called RadarScope, radarscope.tv if you're interested in using it. Yeah, it's about, I don't know, $15, $20 a year for the pro version. And you have to look at individual radars, but it lets you look at the raw data the way meteorologists would look at it if they wanted to see all the details in the radar data. Everybody used to use soundings to get a soaring forecast. I'm finding now that I don't use radiosondes anymore. In windy.com, there is a way of getting that. I should go back and show you how to do that. In fact, when I'm done with this, I'll go back and show you how to do that. Windy.com will show you the radiosondes. They're so far apart, and they're only every 12 hours. They're really not that useful. There used to be, and still is, an interactive SKU-T site called rucksoundings.noaa.gov. And if you go to this link here, I did a tutorial on how to use that website in that PDF here. In fact, this PDF is my presentation, but if you go into it, there is a link in there, a bit.ly link, a short link with a video and sound of how to use that site. And probably the easiest way to get a local SKU-T, it's not going to be an observation, but it's going to be from the high resolution model, is from SkySite. You just go to hit the SKU-T button and then click on some point and you get a really good SKU-T for that point. There is no such thing as getting a radiosonde SKU-T by interactively hitting at any point. There's just not very many of those radiosondes across the country. Hasn't changed, but there never has been very many. If you want surface observations, mesowest.utah.edu. Again, this one's a little tricky to navigate, but it does give you a lot of surface observation, automated surface observation data. Did you know that Southern California Edison has a huge number of automated stations in the mountains? One of them is right off the end of the runway. It's Crystal Air, and the quality of the data is superb. You can get it through this website. And then the METARs are available on aviationweather.gov. You navigate around on that, you'll see that and many other aviation weather products. By the way, they're coming out with a beta version of this, which will be implemented in a few months. They're about ready to implement it. Well, I said on here I'd do a quick look at satellite and radar. So why not? Does anybody object to that since we're all here?
Keep it going.
Let's see. Where's my, there it is. Share. Okay, I gotta go to another weather. Let's go to the radar site. MRMS Ops Product Viewer. There it is. It doesn't look very useful, does it, right at this point? Well, what you have to do is click on Auto Update, Loop Image, and enable mouse wheel. Oh, and by the way, forget about trying to use this with a smartphone or a tablet. You want a desktop computer with a mouse. It's really just designed for that. So you have to recenter where you want to look at, and then roll the mouse button. That's why this is enabled over here. Now let's take a look at the precip up here in Northern California. There it is. You can't see the map under it? Go to the opacity and turn it down and you can see. Very nice. If you want to see where the heaviest is. Now this is cycling in 10-minute steps for 6 frames. You can, if I'm really interested in examining something, I'll go to 6-minute steps, 36 frames, and it'll go back in time more. And the part that, oh, you're also selecting composite reflectivity, CRF. There's many other things here. I don't find them that useful for what we want to do. Echo top, but it's in kilometers if you want to do the conversion for the thunderstorm tops. But composite reflectivity of radar, what that means is that's the highest reflectivity from the ground, from the lowest elevation angle at a point to the top. And that one really gives you the best picture. If you want the lowest elevation angle, you get this base reflectivity. But if you want just an accumulation of the highest in any one point, the radar does multiple scans at different elevation angles, but the mosaic makes it look like it's one nice little thing. But the radar is actually can't see everything all the time. That's why the mosaic is good, because you're getting multiple radars. If you use radar scope, you're looking at one radar, you have to switch around to a bunch of them to see the weather. The way I look at weather is not as easy as the 11 p.m. news when they show you this nice simple briefing, which takes about 1 minute and 30 seconds. Everything's very simple there. Okay, so get the opacity up, that there. Oh, and if you want to stop it, you just do that. Or no, if you want to stop it anywhere, you just move the mouse in here and move it back and forwards. And you can see where the heavier echoes are and at what time they went through a particular location. Okay, that's the MRMS product viewer. Now the other one, if you want to look at satellite imagery, satellite, okay, so you can't read this, but this says weather.cod.edu/satrad. And with this, you have to pick, well, if you pick a regional view, there you go. You've got the Western United States. The problem with that, and you have to pick one of the 16 channels from the radar. Oh my God, this is complicated. Well, clean long wave IR is the infrared photo, and visible red is the one for the daytime. Those are the two you want to look at. There's also water vapor, which is just for a longer talk on satellite interpretation, which I won't get into. But long wave IR is the infrared photo. The trick here is to get a map background on this thing. You go to this little globe right here. And then I put on counties, state routes, highways, interstates. And they're all Now you can see the outline of California with interstates and counties. Would be a little easier if I went to a localized sectors. This is zoomed in on a smaller box. And there you can see it. You have to go down here and start the animation. If 24, by the way, the radar, the satellite imagery is every 5 minutes. So that would be what, 6, that'd be 4 hours worth. 24 frames divided by 6 is 4 hours. If you want to see further back, you can go all the way back to 200 frames. That's all I'm going to show you there. That's enough. Each one of these, as I say, requires a lot of playing around with to get familiar with it. I'd be curious to see how many of you have used this site before and are familiar with it, but we'll leave it at that. Okay. So I'm going to go back, new share to is it this one? Can't remember. Yep. Observational data. I'm just about done. If you want the latest updates, I have another website I go to. It's called rapidrefresh.noaa.gov. This right here, you can pick the HER model any hour, and it'll forecast out 18 hours. Every 6 hours goes out 48 hours. And in that, there's like 50 different maps you can look at. And the ones that you would be interested in for soaring forecast would be height of the PBL, planetary boundary layer, which is in kilometers above ground level. The second one would be a radar reflectivity, see where the showers or thunderstorms are, especially during the summertime. And there's one called mean vertical velocity. I'd have to show you this, or you'd have to browse it and figure it out by experimentation. But the mean vertical velocity in the layer would show mountain wave activity. So it would be much easier just to go to SkySight and do this, which, by the way, the HER model is on SkySight. But the difference is if you go here, you can get more up-to-date model data. It runs hourly out to 18 hours. SkySight, I think he updates it every 6 hours, which is fine. But sometimes in the morning, like at a contest or a big event or something, I want to see what the very latest is. That's my whirlwind tour for weather. Does anybody have any questions or would like me to go back to anything?
Yeah, go ahead. If folks have any questions, I can also, there's a couple of comments that were tossed in the chat during your discussion there. Dan had a couple of comments about windy. Windy is good at smoke forecast, which of course, you know, us in the West, we do need to know about fires and smoke and situations. So Dan, thank you for indicating and mentioning that. Dan mentioned also that I think he's asking to show waves on SkySight. I thought you mentioned it briefly. I don't know if you did want to go into waves on SkySight, Walt.
I can.
Yeah.
Yeah, I can. Let's see. Let me go to SkySight here and reshare. Share screen. Where is it? There it is. There's SkySight. Yeah, if you want to look at waves on SkySight, you go down to wave section and this left menu. And you look at the vertical velocity at any one of these levels, anywhere, well, I recommend anywhere from 10,000 to 29,000 feet. 16,000 feet is a good reference level. And there it is. Not much.
Not much.
The wave activity is very weak
up
here in the Minden area, but there's a little
Well,
bit.
click forward a few days and see what happens with this front coming through.
Yeah. Oh, yeah. There was talk about, there's wave off the coastal. Ahead of that front going through on Saturday morning. Yeah, now we're getting a good wave. Yeah, now on Friday. And you can actually
go fly out of Lone Pine.
Go up here to winds, put 18,000 winds on. I didn't want to do that. Barbs. Let me go back down to 16,000. I thought I could show wind barbs on there, on top of it.
Hmm.
Yeah, if I do that. Oh yeah, there we go. I
There you
just
go.
hit, I just hit the barbs tab.
Mhm.
And see, we're looking at 18,000 and showing 50, 55 knots.
Yeah.
Yep, and you turn to Mammoth and return,
Yeah.
or Bishop and return would be a good thing to do. Oh, that's at 6 p.m. That'll be after dark. Yeah,
So
but
good.
late afternoon it's working. Here's 1:30 p.m. Yeah.
So what's the altitude for those winds though?
The winds are
Oh,
18,000.
18,000
It's this
also.
drag up here.
Right. Yeah. Yeah.
I thought it used to show the wind barbs. You went up higher.
Also do
Oh,
a cross section of the wave.
yeah, there
too.
it is. Yeah, the cross section, you click on cross section here. What did I do? I do wrong here. Let's go through Mount Whitney there. Where the heck is this? Come on, there, and then,
There you go.
damn it. I will just drag it up there.
There you go.
Doesn't look very strong. Well, I guess it's not very strong at that time. If you go to the late afternoon, it's stronger. Oh yeah, there we
There
go.
you go. Yeah.
So you can zoom in here. There's Lone Pine. Yeah, it's pretty close to Mount Whitney. Independence.
Yeah.
Right there at 85 knots and over 12 knots
Nice.
from 3,000. Oh wait, this is meters. Wait a second. Yeah, there's thousands of feet. So yeah, 10,000 feet up to 29,500. The tropopause is pretty low, I would think. See, it dampens out as you get up around 36,000.
Yeah,
If you go over here, you can look at UT, put it there, and then there's your winds. You see, what is the tropopause? It's where the lapse rate becomes very stable, right about there. And that point is 36,000. See, that's why the wave doesn't, just damps out right on there. And then up here, this is it's not actually warming. The ISO lines of temperature are these slanted lines on a 45-degree angle. So from this point, minus 77 to this point, minus 75, it's essentially, that's the stratosphere. And this is the demarcation between the stratosphere and the troposphere called the tropopause. I wonder what that is. That must mean turbulence, I'm guessing. It's probably wind shear, and that's why Matthew Scudder shaded it there. And you
That's
see the
cloud.
winds. Yeah, it would be cloud cover. You're right. Temperature dew point's close. Yep.
Right.
And you notice the winds go from 60 knots up to 100 knots. And then they drop off a bit. 90, 85, 75 as you're in the stratosphere. Okay, is there anything else anybody wants me to kind of show them here? There's tons of things. I mean,
Yeah.
every website is unique. You got to learn how to navigate it. And that's why, you know, if you don't do anything else, you go to SkySight, you look at the thermal height for the day.
Right.
You look at the winds, you look at the time section, how it evolves during the day compared to the day after or the day after that. If you have flexibility on what days you can fly. Of course, in Antelope Valley Soaring Club, it's easy. You just go look at Saturday, right?
Right. Yep.
Or Crystal Air, what is it? Friday, Saturday, and Sunday.
Yeah. We're looking
So-
to expand on Sunday.
Anybody have any questions? Just shout it out.
Yeah,
Yeah, go
model
ahead.
question. Does Icon have anything to recommend it so far as we're concerned? The
Not
German
pa- Not
model?
particularly. Let's take a look at this. This is 1700 Zulu. This is 9 a.m. Friday. This trough is approaching with a 200 knot jet. This is 300 millibars right here. Flight level 300. Let's look at icon. Pretty similar.
Hmm.
No, the answer is not really.
Not really. And
Yeah.
what's Rufus going to do for us that her doesn't, that,
Okay, what's happening is the NOAA modeling people and National Weather Service have had way too many models. We've had the global model and then they have way too many models and it's just too confusing. And more importantly, to the people who are paying for it in the headquarters and the Congress, it's way too expensive. They're spending way too much time trying to maintain all these disparate models. So what they're doing is they're going to a uniform framework and they're converting everything to this uniform framework so that what we'll end up with is the NAM will be retired. All these NAM of high resolution models, there's like 5 of them, they'll be retired. And all you'll have left, and the RAP will be retired, deprecated.
Hmm.
What's left will be something called Rapid Refresh Forecast System, or RUFUS. And it'll cover a large area of North America and off into the Pacific. And that will be the substitute for all those models that got deprecated.
Okay.
It will be just fewer things to look at, reduce complexity. That's the answer why.
thank you.
Oh, and also there'll be 9 other model runs simultaneously, but they call ensembles. So you can actually, if you pull the data out, you can get probabilities of occurrence of a certain temperature or rainfall ranges, or I suppose that you could even do probability of thermal heights below 10,000 feet max for the day. I noticed that Matthew Scudder is going to give a talk at the convention on ensembles. So he's been thinking about this a lot for the last couple of years as to how to incorporate it into a future upgrade. So I don't know what he's up to specifically, but it'll be along the lines of, what is the probability of something occurring that's soaring related?
Okay, well,
Any other questions? Okay,
Okay,
we
great.
have,
Hey, Walt, I have a question. What is your preference in forecasting convergence? I guess specifically, or I guess in Southern California,
my preference for viewing that.
forecasting it.
Forecast. Well, I look at SkySight.
And the answer is SkySight.
You look at a high resolution model and you look at the wind field and you can see where the flows join together. And in fact, you don't even need the convergence product. I'm going to try to see if I can find an example today. First of all, I need to find the right day. Yeah, let's try this. Let's try Friday. There'll probably be a big, strong southerly flow out of Cajon Pass here.
Right.
Let's see. Winds. Let's go down to
Five.
surface winds. What am I looking at here?
I got surface now.
I think trying to figure out what I'm looking at.
That looks like
So even I have a hard time figuring out what I'm looking at. You guys must be dazzled. lot
Just
of it,
below
right?
winds, Walt, just below winds. You go down a few more.
It's a surface wind
Surface winds.
velocity.
These are surface winds. There we
yeah.
go. Where is convergence?
Right there.
You're on it right there.
Right
Right
there.
there.
Okay, there
Yeah.
we go, right there. And then I would turn on streams. So if you turn on the particle streams rather than wind barbs, if you turn on particle streams, you can see the flow coming out of Cajon Pass here. And then you can see the northwest flow here. This is the El Mirage shear line. Runs
Right.
from Phelan to Crayfield, right, Christopher?
It does.
out to
yeah.
Hellendale and
Mhm.
Barstow.
Yep.
And you notice how the little particles kind of aggravate along there.
Yep.
And then this light green, darker green and yellowish green, that's the convergence.
Yep.
So to answer your question, what do I look at? This is what I look at.
Yep.
I sometimes won't even turn on the convergence. I might just turn on surface wind.
Right.
And there you go.
Yeah.
Anybody who lives out there and is driven across Victorville, you know, that southerly one, here it is, 20 knots out of the south,
Mhm.
and then it goes to light and variable in the convergence.
Yep.
That's
Spreads
what
out
I
to
look at. And it, again, if you go to that HER model at that I gave him the link for optional sources, you can actually see what that's doing. Well, actually, you could do it here too, probably. Just click on HER. Let's see. Well, I don't think he calculates convergence for the HER model. In fact, I don't think this really changed anything. I still think this is using his SkySight high resolution model. So maybe that doesn't work. But anyway, you can go to the HER model on one of those other websites, that I showed on the slides, and look at the low level wind field and just eyeball. They don't have a convergence product, but you just look at the low level winds and see where they kind of converge.
Well, Wendy
But
would
this
tell you
does a
the same
beautiful
thing.
job of it, doesn't it?
Yeah. But Wendy does a similar thing though, too, doesn't it?
Yeah, well, yeah, that's
It's
right.
not quite as
Let's take a look at Windy. Let's
not
go
quite as
to
not
so
quite as
let's
pretty, I guess.
let's go to Friday. So that would be Friday at
It's like 3 p.m.
2 p.m. 2200 Zulu. So now I got to go down to here, surface. Wind
on
gusts.
Mm.
Hmm.
Yeah, wind
Okay,
gusts
well,
are
I'm
just
looking at
regular wind.
icon. There's the problem.
Yeah,
Let's look at the HER. Oh, there it is, right there.
same thing.
So you go to the HER model, or you can go to the NAM 3 kilometer. It probably is not quite as good, but the HER model looks very similar to what we were just looking at there.
Yeah.
Much more prominent though with SkySight. And you can see the convergence out here, north of Yucca Valley.
Yep.
This area in here, by the way, is restricted area. Oh, one other thing on Windy, if you go to the menu and you go to setting, no, what is it? Menu.
Show your
You go to Windy
restricted,
plugin. People have written
uh,
enhancements to Windy, and one of them is called airspaces.
there we go.
And it's loading airspaces from all over the world. So one of them will be United States. And then when that gets done, the United States.
Well, it's gonna take a while.
There it goes. Okay, I had to zoom back in again. I got to go back to the HER. There we go. So now you have airspace on there. Cool, huh?
Yep, that's good.
So there, and then I guess I could pick the thermal height. Let's see what the thermal height shows, just for the heck of it. Thermals. Let's see what it shows. Well,
Yeah. Help him.
it's so-so. It's
Yeah.
better than nothing.
Yeah.
Nice high area here. Let's see, what does that show?
Is that Yucca?
Yeah,
No,
it's
not
just
Yucca.
northwest of Yucca Valley.
that's like
Oh, it's Big
Landers.
Bear.
Big Bear
This is
Land.
Big Bear Airport. This is
Okay.
Yucca Valley.
Yeah.
And it shows 6,600 for a middle of winter. 6,600 feet's pretty good, MSL, right?
Yeah.
It's not bad. And Victorville, 6,700. If you go to Palmdale, Lancaster, it sucks. But,
Yeah, I'll go out to 29 Palms with my glider point out in 29.
incidentally, you can turn on under more layers. You can turn on, where the heck is it now? Oh, I know where it is. It's right. No, where was it? more layers. There it is. If you turn on airports, for some reason I turned it on once and it doesn't turn off. But these little green circles here are METARs.
Okay.
And so if you mouse over them for the current observation. So there's a lot to this, Wendy. I mean, it took me quite a number of years of ignoring it, saying that this looks too wimpy to me. But now that I've gotten into it, it really is a beautifully designed site. It's extremely fast. It uses the graphics processor in your from WebGL, and everything is really fast on it.
Wasn't it developed by the paraglider crew people?
I
thought
don't
it
know.
was.
I don't know where it originated. There's a lot of paraglider enthusiasts because
Yeah.
they have a thing here on them for them. I don't know what that gives you if you turn on paragliding. Oh, it just shows you paragliding sites. Yeah. Webcams, there you go.
Yeah, there's a lot of fun. There's a lot of good stuff for Wendy.
Yeah,
Wendy's
there's a
great.
lot of good stuff on Windy,
Yeah.
and experimenting with it on a rainy day coming up this weekend, you could learn more.
Yeah.
Okay, any more questions? I'm at an hour and a half now. And that was the whole point of my talk, was just to kind of take you through the things that I know. And, you know, ask your
Good.
question now or forever hold your peace. When I'm out at the
Was-
glider part, it's really hard to show this stuff. So if you're
Walt-
interested, ask.
Michael's asking, can cloud streets be forecast with SkySight? I'm not.
No, the cloud
Yeah.
streets are things that require very high resolution models, like 1 kilometer or, you know, 200 meters. The cloud streets show up. The wharf model is a framework that's used in many, many, many places. Universities, NOAA, or other weather organizations use it, and you can set up a whole bunch of different things. Matthew Scudder uses it. But one of the things that it can't do is get the resolution down below about 2 kilometers, 1.5 or 2 kilometers, because all the assumptions on thermal turbulence break down. And you actually have to forecast the other turbulence parameters directly into what they call a large eddy simulation model. And there is a large eddy simulation model for WRF. And I was looking at some today when I was at a convention, at the American Meteorological Convention, watching papers. To give you an idea, it's being used a lot in campaigns of the boundary layer. And in those models, when they run them, you can actually see the cloud rolls very easily.
Oh, wow.
And no, actually, even the 3 kilometer model, you'll see lines of lift out here in the Western Mojave Desert. You'll find kind of a crude version of it. You know, one line coming out from Rosamond towards Red Mountain, another line coming out from Tehachapi Pass towards Trona. And but those are not the kind of rolls I think you had in mind. There's lots of smaller scale cloud streets like that. But those cloud streets and rolls will show up in these LES, they're called large eddy simulation models. WRF is only one. All the models now have a LES version of them. Why don't we see more of it? Well, it's about 10 to 20 times more computationally intensive, or 50 times. In fact, I saw a fascinating presentation today where a guy in Germany simulated dust devils. And he wanted to find out at what resolution did they have to go to have the turbulence and the physics that would forecast the triggering of dust devils.
Whoa.
And he found out that it started at about between a 1 and 5 meter resolution of the model. And when he ran this model over a 4 by 4 kilometer area in a little box, he had spontaneously occurring dust devils that looked just like the real thing. And he said, optimally, it would probably be best to have it at about 0.6 or about 0.5 meters. But so if you have enough computational power, yeah, we could have thermal cloud streets forecast and dust devils and everything. But it's probably going to take a lot more horsepower, like 1,000 or 1,000,000 times more to be able to do that. Oh, somebody on another talk like that gave the estimate of running the LES model. You could run, they have a new version that runs on the graphics processors, the NVIDIAs that we have on some of us have on our computers. One of those graphics processors can now run the WRF LES. And one of those big NVIDIA monsters in a computer, even a small one, could do a small simulation for about the size of the city of Boulder, Colorado. But if you wanted to cover the state of Colorado with that, say 200 meter, 100 meter resolution, reminder, we're looking at 3,000 meters, 3 kilometers. So if you want to do all of Colorado, it would take 12,000 GPUs to do that.
Okay. Not gonna happen
Hey,
anytime
Walt,
soon.
can you show me, I got windy up. I'm trying to figure out where that airspace plug-in was, and I'm not finding it again.
Yeah, install Windy plugin on the menu.
Oh, I'm not seeing that, so let's go back again.
Yeah, go to the
got-
pancake menu in the top, very top left.
Do you have to have premium? Because you have premium.
You
You
know,
might-
I don't know.
You might need to have premium. I'm
Why don't
guessing
I, why don't I log out?
if Bill doesn't have it, maybe, let me
Well,
try
let's see.
mine.
No,
Let me see
it's
if I
in
can-
there. Install Windy plugin. I just logged out. So do you see it?
And maybe,
It's
because I'm
this
looking at it on an iPad.
It's
and
this
I'm not
menu
seeing-
here.
Oh, it could be.
There's settings, favorites. Oh, yeah. Yeah, if you're looking at the Windy version, the Windy app, it's not on the Windy app. You have to have a web browser,
Computer browser, yeah.
desktop computer of some kind, Mac,
Okay.
Linux, Windows.
Mhm.
But you will see that there, and that's nice. Who was asking that question?
Okay, that was Bill.
Okay, Bill
Bill.
Palmer. Okay.
Okay, well,
Okay.
I think we've kind of run the gamut of the topic, and as always, Walt, you're great, a lot of detail, a lot of information, and
Yeah.
stuff to chew over. And remind people that I'll take this recording and put it up on YouTube. So if you want to rerun it and watch parts of it or segments or whatever, it'll be there for you to browse and view at your beck and call. So just open your YouTube browser or YouTube app and look up Antelope Valley Soaring Porch Chat and all those different ones. There's the ones from last year, actually, a few of them up there as well. So please do go and check out that and give it a good old like and thumbs up, and just come back to us and see us next time. We're going to have Dan talking about Hawk Vario, as I mentioned, and got some, Bill's gonna be coming back, Keith Schwab's coming back, Zach Gamache will be back. So I've got a pretty good lineup of different speakers for the
Yeah.
season. So please do join again, and thanks for joining tonight.
Yeah,
And-
I appreciate you getting me to study all this. The trick is to learn all this and focus just on a few things so you can get it done quickly and
Yeah.
enjoy the rest of your life and flying, and not get all wrapped around an axle with all this detail.
Yeah. The detail sometimes is fun. I get get into that rabbit hole, and then I look at stuff and I'm not even sure what looking at, but boy, it looks really cool. Those radar
Yeah.
images are amazing. But
On
I'm
a
not sure
rainy
what it
weekend,
means.
yes.
Right. Otherwise, I'd be outside flying. Or
Good
doing
night,
something
everyone.
else. Thanks, Walt. Take care.
Take
everybody.
care.
Thank you
Bye-bye.
very much. Bye-bye, everybody.
Bye-bye.